hear me? I have a co-presenter with me, actually, Reza Zomaradi from the University of Toronto. So whatever I say, I try to back up with not just hypothesis or back up with data. So we have evidence behind anything we do. And I would like to start with what the future might possibly be for all of us who are really interested to keep our brain healthy and maybe enhancing it. And the brain is complicated, as Zoran said, but maybe there's an easier application to do that. And I'll start with a story that was headlined in Australia last weekend. This gentleman was a retired member of parliament. He had Parkinson's disease. Now, what he did was he read studies, reports about what happens when you deliver light energy to your brain, and he looked at a picture like this. He's a helmet, but it's not something out of a science fiction movie, but it's really a researcher at Boston University having a helmet of hundreds of LED to the brain. But after 2 weeks, this gentleman walked into the office of a researcher I happen to know at the University of Sydney, and his recovery was quite amazing. So I guess it was really interesting, and the Australian national newspaper made a story out of it. We were featured. Now, what it means is, that hints the possibility of doing something with the brain with light energy. He used red and near-infrared light. And I want you to just remember this term, photobiomodulation. Previously, it's been known and commonly known as low-level light therapy. And it means, using light to modulate the body, a living organism. Now, it can get really complicated. I get questioned, how do you know this happens? What's the mechanism? I think it's fairly established. The basic foundation really is the activation of the mitochondria in the cell when the mitochondria is not functioning optimally. It is receptive to red and near-infrared light. It starts to synthesize transcription factors that result in the healing of the cells and reduction of inflammation and so on. This is a slide that shows where it's leading to. We're getting, the tissues responding. You get, the synthesis of brain-derived neurotropic factors that result in neuronal health and growth. You're talking about reducing edema and a bunch of things. So the studies have been done in the past is well researched. You can look, you can actually Google photobiomodulation, and you get really quite a lot of information. I don't really want to go too much into this. It can take an hour, but I want to go into more interesting things. Now, there was a high review paper done recently, and they continue to come up. And what we're getting out there, research shows that in human studies, you're getting a number of neurological conditions responding, traumatic brain injury, Parkinson's disease. You're talking about strokes, and studies have been done. People responding in coma situation. And for us, we've got evidence as a group ourselves, evidence for Alzheimer's patients responding significantly. So animal studies, cover a bunch wider indications too, like Parkinson's disease. There was a paper done, but it's not published. But we're actually planning to do with that particular Australian university, and they're applying for a grant to do that study. So it's quite promising. And here are some of the reports that have come back to us. People in meditation, I know a lot of you are interested in. I'm going to talk more about it. Alzheimer's, where we're involved in, traumatic brain injury, and so on. We have a lot of products in the field already. We exempted from FDA regulations as a general wellness device. We're out quite a lot. A number of you actually have our devices, so thank you. Reports keep coming back. We don't solicit, but it covers a lot of areas. I think traumatic brain injury is a big one. Today, because of the word of mouth that's getting around, more and more dementia patients are using our product. But we really want to do a clinical study, and that's going to start pretty soon. And I want to talk a little bit on that. So we published a paper a few months ago on early results with Parkinson's. The change and the improvements have been really significant. When we compared, to the common drugs for Alzheimer's, it is at least 7 times greater. So this is the device we used. It was the neuro before, pointing at strategic positions of the brain, from the nose to the hippocampus, the memory area, and then also on the top of the head. And I think Zoran would like it. We're pointing at the precuneus up here and the nodes of the default mode network, highly associated with Alzheimer's disease, and it's really the template for good brain health, actually. And this is one of the cognitive assessments used, which is the mini mental state exam, MMSE. The change over 12 weeks was 2.5 points, and what it means is it's really significant because something like the commonly used drug was way less than 1. So, and we use other cognitive assessment scales, but the functionality was very visible too. We had all that. You can, actually check out the paper. But what's really interesting and actually confirmed that Alzheimer's is a strongly degenerative disease is when you stop, your brain just goes downhill again. That's why it's important that we have home-use, user-friendly devices. So we had that with earlier devices, but MIT actually published a really interesting paper showing that when you pulse, so that earlier one was pulsing at 10 Hz. This one pulses at 40 Hz. It follows a number of studies. MIT kind of confirmed that if you pulse at 40 Hz, it activates the microglia in the cell to help remove this beta amyloid plaques, the biomarkers for Alzheimer's. So we did that on Barry, which is a subject we pulled out random. He had kind of moderate, trending to severe Alzheimer's. And his improvements was remarkable. I can't ignore it. It could be a fluke. But when he walked into the clinic, he was with his caregiver, his sister, who is also a trained therapist. He wasn't making eye contact. He wasn't relating in a social environment. And some of you who are familiar with Alzheimer's disease know that there's very little engagement. So within 2 days, I get calls from the sister, and he said, I'm getting my brother back. He's making eye contact. He's engaging in conversation. A few days later, he was improving. He's becoming more independent. And he was starting to crack jokes again. So actually, by the end of the 3rd week, you can't tell that he actually had Alzheimer's. But it was really, really encouraging. But questions are asked, is it a fluke? Does the light, I get this question all the time, does the light really penetrate the brain? Does the brain respond? So I got to get data. And so I think a really quick, easy way is, and a number of you are familiar with, the EEG. So here's one, somebody that we did at a show, that was Jack. He had electrodes for EEG, and we had the neuro on top of it. We can actually see the response live. I can. Can we play this video? Okay. It's 1 minute clip. Sound?
At Jack, we've been seeing him without the stimulation, and now what we want to do is turn the stimulation on and see what we get. Yeah. It's both. Could you get that just from nasal? Yes. I bet.
So someone who doesn't have a lot of money, they can afford a device, nasal one,
that seems to be, like my professor said, a testable hypothesis.
Okay, before I forget, we actually plan to do a live demo at the V-Light booth outside. After the session that was supposed to finish at 4 o'clock, I'm not sure what time it's going to finish with the delay. But feel free to come so you can experience and witness it. It's pretty cool. But I want to, like I mentioned, Riza actually independently from, he's from the University of Toronto at Kennedy Center. They're actually at the cutting edge of understanding, treating the brain with non-invasive stimulation methods like TDCS, TACS, TMS, and hopefully today is going to be PBM, which is photobiomodulation. He'll talk about the data he's got.
Okay, good. Exactly, this is the time I joined the company to answer if this device is really working or not. And for most non-invasive brain stimulation, the main question is, does it really penetrate? Does it really affect the ongoing brain activity or not? And it could be RTMS, it could be TDCS, or different electrical or magnetic field. When I heard about the light and said, oh, light probably doesn't do anything because electrical activity is really the language of brain. This is what we learned. The electrical activity is the language of brain, the action potential. And what could be the role of light here? Does it really penetrate or not? So traditionally what we are doing for the investigating the non-invasive brain stimulation, we are using fMRI, that's very expensive, or using the EEG with different biomarker to see if the brain response or the ongoing brain activity is changing in response of the intervention. We applied exactly the same method here. We record the brain activity at the rest. That was the most simple task. Then we have the neurogamma photostimulation for 20 minutes, the standard protocol that we are using. And again, we record the brain activity. We compare what's the change. Is it real change or it's the placebo effect? Is it really the subjective or it is really neurophysiological change? And is it going
big green arrow, yeah.
This one, okay. We designed double-blind crossover active and sham study to control for placebo and active stimulation. Two groups coming in 2 weeks. One, they come to, this is healthy population. First, we check it for the healthy, feasibility, safety, and if there is any effect. We have one group with active, one group with the sham to receive the active stimulation and sham stimulation. Surprisingly, well, sham also has a big effect on the brain activity because when you are sitting, relaxing for 20 minutes, the brain activity is changing. That's what everyone was talking about, meditation, relaxation. That was not surprise. And when we are putting this device, also we see the change. And we compare which change is bigger or more significant. This is what we find. We find when we have the active photostimulation, exactly with these settings that we used for V-Light, we have significant change in brain activity. So it was really shocking for me. It's a big news, I think, for the people who are doing the non-invasive brain stimulation, that it gives us another tools, another stimulation, non-invisively, painlessly, that you can talk with the brain. And when you can talk with the brain, you can modify the ongoing brain activity, or you can lead it to one direction if you wish. But interaction was not that simple. It's not like shifting everything up or shifting or decreasing everything. The interaction was in the frequency-dependent manner. According to this study, it's like 20 subjects. What we found, it inhibits low frequency. It decreased delta and theta, and increased the higher frequency, alpha, beta, and gamma. And we find it a statistically significant result and level of the cortex in the sensor. And for the case we had, we tested this device, actually the company tested the device on several subjects, but I succeed only to record one patient for several times, the berry that we had in one slides. And exactly what I find for one case of Alzheimer's disease, we find exactly the same pattern. This device, every time it shows lowering delta and theta, increasing alpha, beta, and gamma. And this is, if you know, with the familiar with the EEG and Alzheimer's disease, this is exactly the impairment in the Alzheimer population. You need to decrease delta and theta and increase alpha, beta, and gamma. And by my surprise, this device exactly doing this job. And we find this pattern for one subject here. And we checked not in sensor level on the EEG. We use the current source density, and well, some people believe it's the very equal information to fMRI, but it's much cheaper. In one brain, it's the active and sham, and difference is statistically significant. But the location of the difference is, funny thing, is not the target of stimulation. And we stimulate the default mode network. But the location that has more significant change, it was really far from the network. At least for this result, you can see it's mostly in the right side, temporal part. And our explanation so far, or what I'm understanding from this mechanism, it's photobiomodulation. It's not like a TDCS or TMS. You don't target one specific area to inhibit or excite one specific neural circuits. With photobiomodulation, you provide the energy for the cells through activation of the mitochondria. And you trust the brain to use this energy. If this neurons feels one link is broken, they activate that link. If one neural circuit is has hyperactivity or hypoactivity, they balance that network. And I imagine this device or photomodulation, if we understand how it works and how we can optimize it or individualize it, it really creates incredible tools for neurophysiology or treating the different mental illness. So I will stop here. I will.
So anyway, in summary, I can't read the text, but so we're talking about significant change. When we direct gamma into the brain, we actually elevate gamma, beta, and alpha, and downregulate theta, delta. And then, and there are several things. So but we are actually confirming that the brain does respond to near infrared light significantly. Now that takes us to a very interesting next step. What can we do now? We have a tool here. We have evidence that we can actually help to entrain the brain, modulate it in a way that will help the brain function better. So this is a prototype. I have it in our booth. You can drop by and see. I can do a demo. You can now, with what we have, vary the frequency. Okay, we've got 10 hertz, 40 hertz, really interesting. What if you're doing 45 hertz, 75 hertz? How about, 20 hertz of beta? That's one thing. Now we're opening up new areas. And when Zoran talked about the possibilities and understanding how you can own that, the possibility of helping your brain, it's one way to do it. But the other thing that also happens in a lot of the conditions is the face lock. When you talk about autism, the attention deficit disorder, you're talking about face locking. Now, and I tested with people. We haven't gone to a clinical study yet, but I've tested with the top thinkers in this area. If you start generating signals between two terminals, out of face locking is high coherency. So they're kind of stuck in that, let's say, lower frequency area. If you direct signals in opposite, like noise cancellation, opposite phasing, there's a possibility of you canceling the phase lock and lifting a person with, say, attention deficit problem out of that area. I know that about 40% of people can't be treated with neurofeedback in some other ways. That may be a way in the future. So I can't read this either, so I would like to move forward to what is maybe possible now, and think about it. You know, as we move forward, we want to also look at some of the challenges that have been faced in the past, and we're talking here, for example, autism. So here's a study seeing very high coherency when somebody with autism is asleep and in slow wave sleep. So this is about face locking, and there is a possibility that if you can break the face lock at that particular state, so that is this possibility. So it is opening the doorway to what is possible for a particularly difficult disease. And I'd like to hand this to Zira. Zira is proprietary to this particular information on coupling.
Yeah, that is, I was thinking, if you want to remember some things from this session, with photostimulation, really we can interact with brain. This is really, really important. And we have really transformative technology now. With a prototype we have here, we can change the frequency, we can change the intensity, we can modify it based off subject, based off each participant. If they need more alpha, if they need more gamma, if they need more beta, they need sync, unsync. This is quite possible with this device. And the funny thing is, when we are saying we're stimulating brain with 10 hertz, 40 hertz, it's not exactly working as a TDCS, we call it TACS.
2 minutes left.
Okay. This device has more wide interaction with the different frequency. Actually, when you stimulate gamma, you can modulate the other frequency. We call it cross-frequency coupling. So it could be phase, amplitude, amplitude coupling. And this is one study that we use the magnetic field. And we find it after depression people, after the RTMS, the coupling between theta and gamma, it was really correlated with improvement of the symptom. And we can have this option with the photostimulation with the new device. And this is the result this is not with photostimulation with the RTMS that recently we published. And we can have that option also for photomodulation, and this is really exciting things.
So let's talk about the future here. Brain enhancement. Now, so I'm going to touch on, based on what people have discovered already. Talking about mindfulness and consciousness, reaction time, memory retrieval, and cognition. So I got feedback actually from the field that when people use this, you can try to, at high level, when they use this, whether alpha or gamma, they feel it. I don't, because I always say I'm like a block of wood, nothing happens to me. But I look at data, and that's how I develop the hypothesis. So, I've got people telling me that what takes them days to reach a certain state, they do it in minutes. So we are planning to do some research with people here on future research on meditation and consciousness. There was a study done on reaction time, directing light to the brain. So, response to change in audio signals significantly reduced. So here you are, directing light to the brain actually improve your reaction time. We have a professional hockey player now who's testing whether he improves his performance in matches and training. Feedback's been positive so far, but let's see. And this is a study done on healthy college students in University of Texas, Austin. Memory retrieval and the accuracy and time improved significantly after one treatment. So that is, they were directing light actually to the temple of the brain. So, and here, when you talk about cognition of the brain, that is actually quite, that's associated with amounts of oxygenation in the brain. So this was published in 2016 by the same group. Oxygenation improved significantly. We find that too in different ways of measuring oxygenation to the body. And so something for the future. Actually, it's not that difficult to think about it. We have we're now able to measure what's happening with EEG. It's a brain-computer interface. We, in the future, with enough data, we should be able to identify signatures of different brain states. And if something is not normal, it doesn't take that much to tell a device that is able to change the various parameters at selected spots of the brain. The frequency, the power, the phase in and out, the time, even down to duty cycle, how much the pulse, the percentage pulsing is on. That is possible. And then automatically direct the intervention to the brain, which we have showed that is possible with just based on the data we're getting and the outcomes. And but people in neurofeedback are familiar with this out of NeuroGuide. So you're trying to achieve, from a condition to a normative state. So basically, it's all green at the 2 lines at the top, and removing all the lines of the bottom 3 rows. This is very possible because this is an example of a platform that's able to read the EEG signals. Now, what we need to do is now transmit the signals to the intervention tool. So thank you, everybody. So let's see what happens in the future. I look forward to sharing more data with you. Thank you very much.